Okay, welcome back to Mr. Hassan's Maths channel. I am now going to go through question number 6 of the January 2021 session of the Pure Mathematics P3 International A-Level Edexcel paper. And this question here is about differentiation. And you've got f of x equals x times cosine of x over 3, x is greater than 0, and we've got to find the first derivative f dash of x. Whoops. Okay, in order to do that, what we need to do is check to see what type of problem we have here. We see we have a product of two separate functions which are not related in terms of any kind of way, so we have to use what's called the product rule. Okay, I've got to use the product rule here. Okay, there's nothing like the chain rule here. This is the product rule, although there's a chain rule inside it. So I'm going to call one of them u and the other one I'm going to call it v. So let's call x u and let's call cosine of x over 3. Let's call that v. So u dash is going to be 1 and v dash, well, if I differentiate sine of something I get negative, sorry, if I differentiate cosine of something I get negative sine of the same thing, but then I have to multiply by the differential of what's inside the function by the chain rule. So this is like 1/3 x. The differential of 1/3 x is 1/3, so I have to multiply this by 1/3. So I end up with minus 1/3 sine x over 3. Now when I use the product rule, I like to always go from there to there. Even whether it's the product rule or the quotient rule, it's always the same for me. I always start from here, although in most books they start the other way around. So my answer is always the other way around, but it doesn't make any difference. It's still the same thing. So we're going to have f dash of x. The differential of this is going to be 1 times cosine x over 3 plus, I'm going to have x times minus 1/3. So I'm going to have minus 1/3 x times sine of x over 3. And then I can just simplify that and I've got my answer. So I've got cosine of x over 3 minus 1/3 x sine of x over 3. And there's the answer to part A. Simple as that. Now part B, it says show that the equation f dash of x equals 0 can be written in this form. Okay, so right now we have no idea how we're going to get there, but we're going to make a start. So let's just write down what they told us to write down. Let's write down f dash of x equals 0. So I'll take what we've got already, which is cosine of x over 3 minus 1/3 x sine of x over 3 equals 0. Let's just separate these so that I've got that on this side. So it's going to become cosine of x over 3 equals 1/3 x sine of x over 3. Now I want to get rid of the fraction, so multiply both sides by 3. So I have 3 times the cosine of x over 3 equals x times sine x over 3. So what do I have to show? X equals k arc tan k over x. So I can see I'm going to get a tan here. I don't mean a suntan. I'm going to get a tan here if I do sine x over 3 divided by cosine x over 3. So if I divide both sides by cosine x over 3, I'll have 3 equals x times tan x over 3, dividing both sides by cosine x over 3. Okay, so now I can say from here, you see, I can see this form coming up now. So I can see something like this coming up. Okay, I multiplied both sides by 3, yep. Okay, I can kind of see this coming up somehow. So now I can say that 3 over x is equal to tan x over 3. Yep. Yeah. Okay, and now I can say that the arctan of x 3 over x is equal to x over 3. Arctan of 3 over x is equal to x over 3. I'm just going to explain something here that will make it clear. I was just stop for a second because I was just thinking about something. I was lost in my thoughts, sorry about that. Now, what I want to explain to you here is we want to end up with, we've got 3 over x equals tan x over 3. Alright, so we see here we've got k over x. Okay, and I've got k over x here, but this is inside the arctan. Okay, so what I'm going to do here is this. I want to have the x here outside of the tan, and I want to have this inside of the inverse tan. Arctan, the arctan of something means the inverse tan of something. It's like the inverse function for the tan. So just a little side point is, for example, when we have, say, the sine of x equals a half, and we want to find what x is, what we normally say is x equals the inverse sine of a half, right? We just normally learn that's what we do. But in fact, what we're doing really, what we're actually doing is we're taking the inverse sine of this side, and we're also taking the inverse sine of that side. That's why you get inverse sine of a half. You're doing what you do to one side, you do to the other. Now this is of the form where you have a function, the inverse function, and you're taking the inverse function of the original function, and they kind of cancel each other, giving you x. As we know, f inverse of f of x gives you x. So that's what happens here. We're doing that to get rid of the sine x, to make it x equals. So we take the inverse sine of this side, and it gives you x. So we take the inverse sine of the other side. That's where we get this from. And then you put that in your calculator and you get 30 degrees or whatever. So what I'm going to do here is something similar. I want to have the x over 3 here freed. So I'm going to take the inverse tan of both sides. So inverse tan, remember, arctan means inverse tan. So what I'm going to do is I'm going to take the arctan of this side. So the arctan of 3 over x equals, and I have arctan of the tan of x over 3. Okay, this is basically what we actually do when we take inverse tan or sine. So the arctan of 3 over x stays as arctan of 3 over x. And arctan of tan x over 3, well, they kind of cancel each other out. It's an inverse function for that. So that will just give you x over 3. So then we can say x is equal to 3 times the arctan of 3 over x. And we can see that's the form that we needed. X equals k times arctan of k over x. So here in this case we can say k is equal to 3. Okay, so that's a bit of a question you have to just manipulate at the end, but I just wanted to explain that little point to you. Okay, we could have done that in anywhere. If I could have said, like, for example, I know that the tan of an angle is equal to 3 over x, then I can say that that angle x over 3 is going to be inverse tan of 3 over x. So you can think of it like that way, straight from here to there. We know that the tan of the angle is equal to 3 over x, so we can say that the inverse tan of 3 over x will give you the angle x over 3. So you can think of it like that, but I was trying to explain the kind of origins of where this comes from. Okay, it's like what we're actually doing when we're trying to get rid of the tan. We're trying to do we take the inverse function of this of both sides. Okay, just like when we're doing x plus 3 and we're trying to find what x is, like x plus 3 equals 5, we're actually applying the inverse of adding 3, which is subtracting 3. So we're getting rid of the plus 3 by subtracting 3. So we're getting rid of the sine for the x by taking the inverse sine of the sine of x. So that's basically just a little side point, really. But there we have the answer to that question. I hope that was clear. So by the time you get to this point here, which is when you change it to tan, because we can see that we need a tan here, and we can see sine of an angle divided by cosine of the same angle, that's going to give us tan, right? And then when we end up with tan x over 3 equals 3 over x, we can see we've got something over x, and we can think, okay, this is the angle, this is the ratio. So what we can do is say inverse tan, the angle is equal to the inverse tan of the ratio. So the angle x over 3 is equal to the inverse tan of the ratio. So that's where we get this arctan 3 over x. And then we can multiply both sides by 3 to leave the x on its own. And we have our answer. Okay, so I hope that was clear. That's part B for question number 6. A bit of a different style question, but it's manageable. And now we're going to have part C. It's about iteration and numerical methods. It says starting with x1 equals 2.5, use the iteration formula xn plus 1 equals k arctan k over xn with the value of k found in part B to calculate the values of x2 and x6, giving your answers to 3 decimal places. So we're going to have xn plus 1 equals 3 times the arctan, which is inverse tan if you remember, of 3 over xn. So if I start with x1 equals 2.5, now what you need to do is you need to show at least one of these steps. So you have 3 times arctan of 3 over 2.5. So you got to show that you know what you're doing, that you're putting in for x2, you're putting x1 over there. All right? They want you to find x2, which we can find. So I'm going to be here in, okay, we did differentiation here. This is, so we got to be in radian mode. Okay, we had differentiated, so we should be in radian mode because this is the result of the differential for that function. So you should always use radian mode, which I'm in radian mode. Okay, so what I'm going to do now is I'm going to say, okay, what I'll do is this. I'm going to type this 2.5. I'm going to press equals. Now that is the answer in my calculator right now. Just to make life easier, I'll show you a little nice method. So that is, that's the last time I pressed equals, I got this. That's the answer in the calculator. So if I press answer from now, this would come up. So I'm going to set this up here. 3 times inverse tan. Remember, arctan means inverse tan of the fraction. 3 over, and I'm going to put answer. Okay, so right now that's going to be 3 times the inverse tan of 3 over 2.5. When I press equals, that's going to be the result of this calculation. And I have to write this to 3 decimal places. So this is 2.62817. 2.82617. Let's make sure. 2.62. So look at that. What I'm going to do is this. I always do this. Let me just do the following. Capture screen and paste. Okay, because in an exam it's not such a big deal with a calculator in front of your face, but here the calculator disappears when I go into this thing. So I'm just going to write this over here. 2.62817. So to 3 SF, 3 decimal places, that's 2.628. That's that to 3 decimal places. Then you want to find x6. Okay, so be careful. Sometimes you think it's going to be just x3. No, it's x2 and x6. Now, what we have in the calculator right now is x2. Okay, if I press it again, I'm going to get x3. Okay, because what's going to happen now is going to take this value that I've just found, and see, this is the last answer that's come out in my calculator. It's going to replace answer. When I press equals again, it will replace the answer with the last answer, and that's exactly what I have to do in this iteration. I have to keep putting this back into there until I get to what I want to get to. So I want to get to x6. So this is, right now, that's x2. Right, if I press it again, so one more time, that's x3. So that's x3. One more time, x4. One more time, x5. One more time, x6. So it's x6 is equal to 2.586. So now I'm not going to write the whole working again. Just show it for the first one. The rest of them you can just write the answers down. So I'll do the same thing again in case I make that silly mistake again where I just misread the numbers for some reason. Okay, so yeah, that's different. So it's going to be 2.586122, which gives you 2.586 to 3 decimal places. So that's x2 and x6. Okay, and that's the answer to part B. So I can get rid of these now. That's the answer to part C, sorry. Now for part D, it says use a suitable interval and find a suitable function that should be stated. Show that the root of f dash of x equals 0 is 2.581. correct to 3 decimal places. So f dash of x is equal to 0. If I go back here, is given by this equation here. This equation here that we started with. Okay, so I can say that this is what we had in the beginning. Okay, so I can use the function, therefore, f dash of x equals cosine of x over 3 minus a third times x times sine of x over 3. That's the function I'm going to use. And I want to show that there's a root of this equals 0 is 2.581 correct to 3 decimal places. So what I need to do is this. This would be 2.581. If I think about the lowest number that could be rounded such that when you round it, you get 2.581. Well, that's going to be 2.5805. If I round that to three decimal places, I'm going to get this. So that's the highest it can be. The lowest it can be before it rounds to this. If it's any lower, it's going to round to 2.5800. Okay, so this is the lowest it can get if it's rounded to give me this value. And the upper bound of this is 2.5815. It means basically, you can think about it like this. That's the highest it can reach. Just before this is the highest. It's like if it's 2.81, 2.581499999, it will round to 2.581. So something just before this is the highest it can be, so that when you round it, it rounds to 2.581. If it's this or higher than this, it's going to round up to 2.582. So just below this value, that's why this is called the upper bound, just below this value, and exactly this value, this is the lowest it can be, and this is just below, this is just slightly above the highest it can be. So we don't include this value, just everything just below it, like 2.581499999 is included, but not 5. Now, any root that falls between this value and that value, okay, will round to 2.581. So supposing this is the x-axis where the inverse function crosses the x-axis, just suppose it goes like this. We don't know how it goes. Supposing it goes like this. This would be the root, okay? And this, if I round this number, it's going to 3 decimal places, it's going to give me this value. Any place in this area, if I round it to 3 decimal places, it's going to round to this value over here. Okay, so that's what they mean by the root is 2.581 correct to 3 decimal places. So how can I show that there's a root between these two values? Well, a root is when you substitute a value in to the equation and it gives you 0. Now, if I substitute this value into the equation, and it gives me, for example, a positive value, and I substitute this value into the equation and it gives me a negative value, okay, then it means somewhere between these 2 points it's crossed the x-axis. Similarly, if this gives me a negative value and this gives me a positive value, somewhere between these 2 points the line has crossed the x-axis. So the root is somewhere between them, because the root is where it crosses the x-axis. Okay, so that's what we're going to do here. We're going to take this expression and I'm going to put into it first the lower bound, which is 2.5805, and I'm going to see what happens when I put that into the function. And I'm going to do the same thing with the upper bound, which is 2.5815, and I'm going to see what happens when I put that into the function. If there's a change in sign between them, then that means somewhere between these two values there's a root. It's crossed the x-axis somewhere between those two values, and if it is between those two values, then whatever root it is, when you round it to 3 decimal places, it will definitely give you 2.581 correct to 3 decimal places. Okay, so that's what this whole thing is about here. So now let's just substitute this value of 2.581 805 into this equation. So I'm just going to do it straight away without writing down all of that. So this is the value. What I'm going to do, I have to take the lower bound and the upper bound. So I have to use these values exactly. So I'm going to take cosine fraction 2 point. In fact, what I'm going to do here is something. I'll do 2.5805. I'm going to store that. Oh, I'll press 05. I'm going to press equals, and I'm going to store that as a. So when I recall a every time, it's going to be that number. So now what I'm going to do is I'll say cosine, and I'll recall a over 3 minus a third, okay, times x, which is, if we call it again, okay, times sine, and then again I've got to put a over 3. Okay, so that's putting 2.5805 in here. Let's see what we get. We get a positive value. You get 3.467 times 10 to the power of minus 4. 3.467 times 10 to the power of minus 4, which is a positive number. And then what I'm going to do is I'm going to go back to what we have here. And I'm going to replace the A with B. Now I'm going to I'll just replace it with the number I want. Okay, which is 2.5815. 2.5815. And I'm going to do the same with this A. 2.5815. Okay, and I'm going to do the same with this point. 2.5815, and now hopefully there's a change in sign. Yes, there is. That's negative 0.3 by negative 3.46. Okay, 457. Negative 3.457. 3.457 times 10 to the power of, what was that? Minus 4 again. Okay, so that's negative. So we can see we have to justify it, right? So we have to mention a little statement that as f dash of x is continuous, it's a continuous function, and there is a change of sign between f 2.5805 f dash and f dash of 2.5815, therefore, okay, a root of f of x, okay, is 2.581, correct to 3 decimal places. Correct to 3 decimal places. Okay, because it's a continuous function and there is a change of sign between those values we put in. Therefore, there must be a root somewhere between those two values, and that root will round to 3 decimal places to 2.581. And that's part D of the question finished, and we completed this question. I hope that was clear. Other questions about, I guess, iteration would be one of the playlists. Another playlist would probably be the trigonometry, we can say, and it'll be under like maybe the inverse trig functions. but in trigonometry basically from P3, and also, as I said, this is also to do with the topic of iteration. Okay, and we can click on this link here to subscribe to my channel. At the top of the page you'll find a link taking you to other past papers you might be wanting to watch. As I said, the first playlist that you'll see over here will be other questions from this same paper, which is January 2021 P3. Okay, so there's the answer to that question. Thank you for watching, and I hope everything was understood. I took a bit longer to explain this question because there's a few concepts I wanted to go through in a bit more detail, and I will see you soon.